Welcome to Study Loop.
Okay, so this question is on the Milky Way and the sun's position in the Milky Way, sun's motion within the Milky Way. We will use concepts of rotational motion, uh, including period and circumference of an orbit. And so we'll start off with the basic fact that the sun moves relative to the center of the Milky Way at a velocity of, let's call this VMW, velocity relative to the Milky Way center, and that is about 220 kilometers per second, extremely fast. Let's convert this to units which will make it easier to work with, to parsecs per second. So 1 kilometer is approximately 3.24 times 10 to the minus 14 parsecs, and a year is approximately 3.16 times 10 to the 7 seconds per year. All right, so now we have something in units of parsecs per second, or I should say parsecs per year. So this is 2.25 roughly times 10 to the minus 4 parsecs per year. That's the velocity of the sun relative to the Milky Way. And then we know that the sun will cover a circumference for a circular or for an elliptical orbit. It will cover a circumference, right? So it will move in a determined direction. And so the sun's distance, the radius of this orbit from the center of the Milky Way, and here is the sun. So that we'll call d0, and that is 8,000 parsecs. We're 8,000 parsecs or 8 kiloparsecs from the center of the Milky Way. Therefore, the circumference, and this we're going to call dmw, meaning the distance traveled within the Milky Way in one orbital period of the sun. That's just equal to 2 pi times this d naught, right? 2 pi times radius is the circumference of a circle. And so this is 16,000 pi parsecs. That's 50,300 parsecs. Now we have a distance and we have a velocity, and therefore the last step is to, or the second to last step, I should say, is to find the time of this orbital period. So the time, t, is just distance over velocity from the classic equations of motion. And so the time, a typical orbital period, is 50,300 parsecs over 2.25 times 10 to the minus 4 parsecs per year, giving you approximately 2.2 times 10 to the 8, or I should say very close to 2.2 times 10 to the 8 years. So 220 million years. That's how long it takes the sun to complete one revolution around the center of the Milky Way. And the sun is 4.6 billion years old, right? And so that's, whoops. So that's 4.6 times 10 to the 9 years. Therefore, the number of, and that's the age of the sun, and so the number of revolutions is therefore 4.6 times 10 to the 9 years over the time period for one rotation, or one revolution, 2.2 times 10 to the 8 years, giving you approximately 20 times that the sun has revolved around the center of the Milky Way, assuming that the speed of this rotation hasn't changed significantly from this value of 220 kilometers per second that we observed today. And that's it.